بسم الله الرحمن الرحيم ربي اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقه قولي. I'm Dr. Hambacha, PhD Diagnostic Ultrasound Associate Professor. Today we will discuss about decibel. So decibel is the unit of change. So any change in any variable can be expressed in the unit of decibel. So this is a logarithmic scale. This is based on 10. We'll see how decibel scale can use to express change in many physical properties, including sound intensity, power, amplitude, voltage, and so on. So if there is any change in these parameters, so it can be expressed in the unit of decibel. But this change will be too huge change, and if it is expressed in an understandable way, in a compact and a comprehensive form, then it is mandatory to be converted into decibel. Think of a decibel scale as a different way to express ratio of two values, and that ratio will be actually a change. When using decibel, it usually helps to determine the ratio first, then convert the ratio into decibel. So a decibel scale is a logarithmic scale, as its name indicates. Logarithmic scale use the logarithm of the quantity, not quantity itself. So logarithmic scale are very useful for expressing data that covers a wide range of values. The logarithm reduces a wide range of value to a much smaller and comprehensive value that can be understandable. For example, uh, if there is any change in any quantity and that is too huge, for example, we said that initially the amplitude was 1,000 and finally it was reduced to 1. So it is a huge quantity and too difficult to be understood. So decibel scale is 1/10 of the Bell scale. The original logarithmic scale is the Bell scale, named after Alexander Graham Bell. The decibel is 1/10 of a bell. Now, since the decibel scale is the logarithmic scale, let's spend a little time to understand about the logarithm. So it's the logarithm. The abbreviation for logarithm is used as log, and the logs that we will keep look at are called common logs, which means they are based on 10. The common log of a number is the number of tens that must be multiplied together to result in that number. For example, a number which has the number of tens in it, that will be its log. The log of number is the power of 10. If we express any number in scientific notation, the power of the exponent of a number will be its log. So now here you can see what's the log of 100. So you can see that there are two tens in 100. That's why the log of 100 is 2. And the log of 1003 and the log of 10,000 is 4. So in this table you can see different logs of different numbers. For example, 1,000 having 6 tens, its power is 10 raised to the power 6. That's why its log will be 6, and so on. Similarly, the reciprocal number have its log according to the number of tens in it, but it will be negative because here you can see the log of 1 over 100 is minus 2. The log of 1 over 1,000 is minus 6. So now we have discussed this question, but once again you can see what will be the log of 1800. So while looking to this number, you will be will fear that how will we be able to calculate the log of or determine the log of 1800, because you are not allowed to use calculator or any log table. So how will it be possible? You can see 1800 is the combination of 1000 and 800. So the log of 1000 is 3. So any number fall between 1000 to 10,000 will have the log of 4 point something. And any number from 10 to 100 having a log of 2, from 100 to 1000 is the log of having the log of 2. And from 10 to 100, 100 to 1002, and 1000 to 10,003, 10,000 to 100,000, the log will be 4. After changing the number of tens will be increased, and that's why its log will also be increased. So here, if you look into the options of the log of 1800, so you will see there is only one option that lies in the range of 3, and that is 3 point something. So the correct option is D over here. Now look at this other example. And you will determine the log of 1 over 150. So you can see 150 is the combination of 150. You can say that it lies 100 and 1000. So its log will be 2 point something, right? So here you can see the options. There will be only one option, and that will be of 2. But this log will be minus because this is a reciprocal number. Now the correct option is minus 2.176. So now it's easy to know about the log of any number which is exactly multiple of 10, around about 8. But for the exact and other numbers which are in between the 10 to 100 or 100 to 10,000 or 1000 to 10,000, for that purpose you will need either calculator or log table. But we will try to do more example without the help of calculator or log table. So now there is a generalized equation for logarithm for decibel, because now we know about the logarithm or the log of any number, but how it will be converted into decibel. So for that purpose we will use different equations. So here you can see the change which is occurring in sound wave that can occur in all the parameters of the sound wave. For example, if the power of the sound waves is affected, then ultimately amplitude and intensity and voltage, each and everything will also be affected. And we already know about the relation between the power and amplitude, and here you can see power is directly proportional to amplitude square. If you talk about the intensity, so intensity is directly proportional to amplitude square. And similarly, intensity is directly proportional to voltage square. This is intensity is directly proportional to amplitude square. And the same intensity is directly proportional to voltage square. Power is directly proportional to voltage square. So we'll use 10 log equation for intensity and power, and 20 log equation for amplitude and voltage. Now express change in power from 10 milliwatt to 100,000 milliwatt in decibels. So how will we be able to express it in decibels? So first of all, you will have to determine the ratio. And the ratio will be final by initial. So this change is occurring in power. So we will use 10 log equation for it, and the generalized equation is written over here. Change any number which will be expressed in decibel is equal to 10 log of ratio, and ratio will be formed by final attainment divided by initial it was. So finally, the power is 100,000, but initially it was 10 because there is an increase in the power of the sound waves. So final by initial 100,000 divided by 10. So 100,000 divided by 10 will become our 10,000, because 10 is crossed with 10, and now we have 10,000, right? So 10,000 having 30 are, it has four zeros are, it has four tens are. Its scientific notation is 10 raised to the power 4. That's why its log will be 4. And that 4 will be multiplied with the base. And base used over here is 10 because this change is occurring in power. So we are using 10 log equation. So 10 multiplied by 4 is equal to 40. So any change which is occurring from 10 to 100,000, that will be comprehensively in a compacted form, in a small form, in an understandable form, that will be 40 decibel change. This is too easy. This is a generalized equation. You can see change in n number, which can be expressed in terms of x, that is equal to 10 log final x divided by initial x. So this is a generalized form of the equation that can apply on power and intensity. So if we apply it on power, then we will replace x with power, and if we apply it for intensity, then we will replace x for the intensity. And if we are using this equation for amplitude or voltage, then we'll square this equation. This entire equation will be squared because we know that power is directly proportional to amplitude square. So here we have squared it. Like you can see, the generalized form of the equation was change in any number, change in any quantity. If it is in the intensity, then change in intensity is equal to 10 log of final intensity divided by initial intensity. But if we apply it on amplitude, then we'll have to square. So if we square the entire equation, then we'll get this equation, right? So this is 20 log of final amplitude divided by initial amplitude. If you use it for voltage, then you will have 20 log of final voltage divided by initial voltage. So for different parameters that can be used differently, and here you can see for amplitude and voltage, we'll use 20 log equation, but for intensity and power, we'll use 10 log equation. Now, we are going to solve some of the example on it, then it will become too easy for us. So here's the Decibel equation for amplitude and voltage. Note that the only change is that 20 log or the base, which is replaced by 20 instead of 10. So we call this equation as 20 log equation because although there is no equation in mathematics with the name of 20 log equation, but it's for the sake of simplicity and ease, we are using here the term 20 log equation. So now there is an example, express change in amplitude from 100 Pascal to 10,000 Pascal. So how will we be able to simplify it? So first of all, we will have to make the ratio, and the ratio will be formed by final amplitude divided by initial amplitude. So final amplitude is 10,000 and initial amplitude is 100. So 10,000 divided by 100. So now here we can see two zeros are crossed at 20 means 100. You know the log of 100 is 2, and here this change is occurring in amplitude. That's why we'll use 20 log equation. So the base will be 20. So 20 and log of 100. So the log of 100 is equal to 2. So 2 multiplied by 20 is equal to 40. So this change will be 40 decibels. So any change of it occur in amplitude whether from 100 Pascal to 10,000 Pascal, so that will be a 40 decibel change. And again, we can have a very comprehensive and simple digit that is 40 decibel. And that is too easily understandable, right? So this change is 40 decibel change. Thus, a change in amplitude from 100 Pascal to 10,000 Pascal will be equal to 40 decibel change. Now try another example. If there's a change in intensity from 1000 milliwatt per centimeter square to 10 milliwatt per centimeter square. So how much will it be in decibel? So first of all, we'll have to make the ratio. So how will we be able to make the ratio? You know, the initial and final values. So initially it was 1000 and finally it became 10. So 10 divided by 1000, that will be ratio. 10 divided by 1000. So by 10 divided by 1000, we'll get 1 over 100. And the log of 1 over 100 is minus 2 because this is a reciprocal number. And this change is occurring and what? So we should know about the uh, uh, this change is occurring in intensity. So we'll use 10 log patient for it, right? So while using 10 log patient for it, we have the log of 1 over 100, that is minus 2, and that minus 2 will be multiplied by 10, so we'll get minus 20 decibel. So minus 20 decibel is that change. So if any change occur in intensity from 1000 milliwatt per centimeter square to 10 milliwatt per centimeter square, that will be equal to minus 20 decibel. Now the minus 20 decibel doesn't affect the amplitude, but actually shows the direction that this change is a reduction. This is not an increase. So this is a reduction amplitude, intensity. Now here there is an example which is a little bit different. So you can see using decibel express increase in intensity by a factor of 100, which is then followed by further increase by a factor of 1000. So this is an example with a different twist. You can see here we haven't provided with the ratio with the numbers, initial and final numbers to make its ratio, but we have only given the factor. For example, the first ratio is solved and the solved number is given to us, that is 100. So that is called factor. So initially there was an increase in intensity by a factor of 100, then it was followed by further increase by 1000. So if we can solve this type of equation by two ways, on one hand we can solve this type of expression individually. First we'll express the change which is occurring by a factor of 100, and then we can express the change which is occurring by a factor of 1000, and then you will add both the decibels. And on the other hand, we first multiply both the changes because both the changes are occurring simultaneously, one after the other. So first of all, we'll have to multiply both of them, and then we will collectively express 10 decibel. So if we are going to express it individually, so this is a change is occurring in intensity. We'll use 10 log patient. So we'll have 10 log of ratio, and the ratio is solved, and it is given over here. The log of 100. The log of 100 is 2, and we'll multiply it with 10. So 2 multiplied by 10 is equal to 20 decibel. So this is equal to 20 decibel. Then we will have to express this one in decibel. Again, we'll have to put this value in the equation, 10 log of ratio, and the ratio is 1000. That is solved ratio, right? So the log of 1000 is 3. So 3 will be multiplied with the base 10, and that will become 30. So there was a twofold increase in intensity, once by 20 decibel, and then it was followed by 30 decibel, and both the changes are equal to 50 decibel because 20 plus 30 is equal to 50. So this is a 50 decibel change in intensity. On the other hand, we can first multiply both 100 and 1000. So we'll get 100,000, and the log of 100,000 is 5 because it has 5 zeros or 5 tens, and it will be multiplied with the base 10 because we will use 10 law equation. This is a change in intensity. So that will become 50 decibels. So both form it's too easy to express 10 decibels. So this is the method which is explained over here. We have earlier discussed about. First of all, they have expressed both the changes individually and then added both the changes, and that became 50. Then they have multiplied both the numbers 100 and 1000. It became 100,000, and then the log of 100,000 is 5, and it was multiplied with base 10. It became 50 decibel change. So in both methods, the end answer, the conclusion is the same and similar, right? Decibel in intensity and power. So for power and intensity, we are using 10 law equation, but for voltage and amplitude, we are using 20 law equations. So for intensity and power, the decibel value for increase by a factor of 2 is 3 decibels. This is another kind of question. Okay, right. So now we have another equation which is also called a 3 decibel equation. And with the help of this 3 decibel equation, we can express other changes which are not multiple of tens. And it's also too easy. First of all, you will have to look for the log of 2. And the log of 2, anywhere you look in the calculator in your mobile or in the log table, so you will have the log of 2 is zero point 0.3. So if the log of 2 is zero point 0.3 and there is any change by a factor of 2, for example, the final intensity, the final intensity is 100 and initially it was 10, so 50, sorry. Initially it was 15, finally it became 100. So 100 divided by by 50 is equal to 2. So this is a change by a factor of 2. So if we know about the log of 2, so the log of 2 we can determine from calculator or from the log table, and here we have the log of 2 is zero point 0.3. So that log could be converted. If the change is occurring in intensity or power, then we'll multiply this this uh, point 3 with 10, and point 0.3 multiplied by 10 is equal to 3 of 3 decibel. So any change that occur by a factor of 2 in intensity and power, that will be equal to 3 decibel, whether it is increase or decrease. If there is any decrease in intensity by a factor of 2, then it will be minus 3 decibel, and if there is any increase in intensity by a factor of 2, that will be plus 3 decibel. Now what is by factor of 2? If any change occur from 2 to 4, 4 to 8, 8 to 16, 16 to 32, 32 to 64, 64 to 128, 128 to 56, 56 to 512, all these changes are by factor of 2. Or if there is any change from 10,000, right? 10,000 to 20,000. So this change is occurring by a factor of 2. If you take its ratio, then 20,000 divided by 10,000, that will become 2. So any change which occur by a factor of 2, that will be equal to 3 decibel and intensity and power. But if we are using it for amplitude and voltage, then what will happen? We are using 20 log equation for amplitude and voltage. So you can see 20 log of ratio, and the ratio is calculated, which is 2, and the log of 2 is 0.3. So now we will multiply this 0.3 with the base 20 and we'll get a 6 decibel change. So any change by a factor of 2 and amplitude, voltage and amplitude, that will be equal to 6 decibel change. But Ahmad अवली शहजाद जी बताइए क्या मसला है अहमद अहमद क्वेश्चन क्या है आवाज नहीं आ रही आपकी
सर मैं कह रहा हूँ कि फिर बहुत
ज्यादा हो गया
ज्यादा हो गया
नहीं ज्यादा नहीं है डेसिबल अब खत्म होने वाला है इनके डेसिबल तो एक बार खत्म कर देना ये नेक्स्ट क्लास में फिर नहीं होगा हाँ बस ये खत्म होने वाले हैं ओके So here you can see if there is any change by a factor of 2 in voltage and amplitudes, that will be equal to 6 decibel change. And if there is any change, whatever that change may be, whether it is increase or decrease. But if it is in intensity and power, then it will be 3 decibel change, right? So, and how that change will be? We'll have some example over here, and you will see that's 2 to be converted in decibel. For intensity of power, the decibel value for an increase by a factor of 2 is 3 decibel. For increase by a factor of 2, the decibel value. For decrease, this is minus 3 decibel. For increase, this is plus 3 decibel, right? So here are a couple of example, and you can see example 1, express in decibel, a change in power from 25 milliwatt to 50 milliwatt. Our meeting will be finished in 10 minutes, right? We are going to try to complete it in 10 minutes. So if there is any change in power from 25 milliwatt to 50 milliwatt, so the final is 50 and the initial is 25. So 50 divided by 25 is equal to 2. And the change is occurring in power, so that will be equal to 3 decibel change, right? This is increase. Now, this is an increase by 3 decibel change. So express a change in intensity from 200 milliwatt to 100 milliwatt. Now here you can see it's a decrease now. So this is again, this is a 3 decibel change, but this is decrease, minus 3 decibel. And you can see this is a change in intensity. That's why this is 3 decibel. Now there is another example. Since you are not allowed to calculate to use calculator, right? So now try this one. The initial intensity is 4 milliwatt and the final intensity is 16 milliwatt. This is a little bit tricky question, right? So this is an increase by this is an increase in intensity, twofold increase in intensity by factor of 2, right? So once intensity was increased from 4 to 8, and then from 8 to 16. So in both forms, there was an increase by a factor of 2, and initially it was 3 decibel, then it was again 3 decibel. So 3 decibel plus 3 decibel is equal to 6 decibel. So any change from in intensity from 4 to 16 will be 6 decibel. All right. Then we are going to do other example. How would you know about the log? Right. This is a very useful equation. With the help of this equation, we can express any change in quantities which are multiples of 2. And there are a lot of numbers which are multiples of 2. For example, if there is any change from 3 to 6 or 6 to 12 or 12 to 24, these changes will also be expressed in this way. If there is any change from 4 to 8, 8 to 16. There is any change in from 5 to 10, 10 to 20, 20 to 40, and so on. So all these changes will be expressed in 3 decibel equation or in this 3 decibel format. This is too easy. So who knew that decibel could be this much fun, right? This is too easy. So here in this table, you can see if there is any change in amplitude or power, voltage, intensity, so that can easily be converted. So if there is any ratio and that changes occur by a ratio of 1 or 2 or 4 or 8, so that can be expressed in amplitude as 0 decibel, 6 decibel, 12 decibel, 18 decibel, and so on. And if that change occur in powers, that will be equal to 0, 3, 6, 9, 10, and so on. And if these are reciprocal numbers, then the change will be a negative. So that is too easy. There is nothing difficult to be explain much more. In spite of that, if you have any question, you can ask your question, or you can write your question. I will try my best to answer it.